Okay, let's take a look at this example. We have the differential equation 3y dx plus x dy equal to 0. We are going to check it for whether it is an exact equation. So our m is what? 3y, and our n is x. We do derivative of m by x equal to 3. Sorry. We do derivative of m by y equal to 3, and then we do derivative of n. Our n is equal to x, right? So we do derivative of n with x equal to 1. So we'll say that this equation is not an exact equation. But what if I put x squared? I times this differential equation with x squared. I would get 3x to the power 2y dx plus x to the power 3 dy equal to 0. Now, my m changing to 3x to the power 2y, and my n become x to the power 3. We do derivative of m to y, we would get 3x squared. And we do derivative of n with x, we would get 3x squared. Now, our differential equation changed to be an exact equation. So that means if we have differential equation which is not an exact equation, we can find a function to multiply to that equation and make that equation becoming an exact equation. That kind of function, we call it an integrating factor. We call x squared in this case because we put x squared there. We times this differential equation with x squared, and then we find out that our differential equation changing from not exact equation to be an exact equation. So we call the x squared as an integrating factor. We call it an integrating factor. So, and how can we find an integrating factor? Actually, they have some formula that you can use. Okay, there are 4 cases for that. Okay, the way to find an integrating factor. You can divide into 4 cases. Okay, just use one at a time. The first case is saying that if we have differential equation in the form of m xy dx plus n xy dy equals to 0, and this equation is not an exact equation. If the term of 1 over n xy times the difference between dm by dy and dn by dx is a function of x only. The integrating factor let me put the integrating factor as mu. Is equal to this. Exponential of integral fx dx. That is the first case. But if it's not follow the first case, you can do the second case. The same if we have differential equations in the form of m xy dx plus n xy dy equal to 0. And this equation is not an exact equation. If this function 1 over mxy times the difference between dn by dx and dm by dy is a function of y only, then an integrating factor is equal to exponential of integral dy dy. So the way is that if you have differential equation and your differential equation is not an exact, but you want to find some integrating factor to change that differential equation to be an exact equation, because this form is easier to find a solution. So the way that you can do is just that go to case 1, see that this term 1 over n times the difference between dm by dy and dn by dx, if it is the function of x only, then you can find an integrating factor by this equation, using this equation. But when you do this and then you find out that it's not a function of x only, it doesn't mean that you've got no way to find an integrating factor. They said that, okay, then go to case 2. Go to case 2, and then you find this term to be a function of y only. Then you know that your integrating factor would be with this equation. You can find it from this equation. But what if it's not? There's still more. Saying that case 3, if we have a homogeneous differential equation but not an exact equation in the form of m dx m dy equal to 0, where x m x y plus y n x y not equal to 0. In that case, then the integrating factor would be equal to 1 over xn xy plus y times n xy. But this case is quite specific in the sense that differential equation got to be a homogeneous differential equation. So you might ask, why don't we use the method of homogeneous equation to solve for the answer in that case? Of course you can, but I think that the way to find the solution by using an exact method is easier than the way that to find the solution by homogeneous method. So that's why, if possible, if we can find an integrating factor, we always choose that way. Case 4. If we have differential equation in the form of y f(x) y dx plus xg xy dy equal to 0. And this equation is not an exact equation. And fxy not equal to gxy. This one is the function of x times y, okay? X times y. Then we can find an integrating factor is equal to 1 over xm xy minus y times nxy. So for case 4 is not just limit to homogeneous differential equation. It can be any differential equation in the form of this. So now your mx is equal to y fxy, and your n is equal to xg xy. Like that. Okay. Now let's take a look at the example. So after you change it to be an exact equation, you can find the answer, or you can find the solution of the differential equation by using an exact equation method. Okay. Now, this one, our m is what? M is x squared plus y squared plus x, right? And our n is what? xy, right? Now, dm by dy, right? What we got to find is the derivative of m by y. When we do derivative of m by y, we take x as a constant. So what do we get from this? Derivative of m by y is equal to 2y. Now we do n by x. What is n by x? Y is a constant. You do as y is a constant, so you would get y equal? No. So it is not exact. not exact equation. So then, in that case, we know that this one is not separable equation and is not homogeneous differential equation. So how can we find a solution in that case? So we got to take a look at this and try to find an integrating factor, right? So first two techniques that we learned before, we can use to find the solution of this one, because it's not a separable differential equation and it's not a homogeneous differential equation. So the third technique that we learned is exact differential equation, but this one is not an exact differential equation. So we are going to try to find an integrating factor in order to change this differential equation to be an exact equation. Okay, start with the case 1. Case 1 said that if we have mdx plus mdy equal to 0, and this equation is not exact differential equation, which is our case, then we can find an integrating factor by using this term 1 over n times the difference between dm by dy and dn by dx. It's got to be a function of x only. If that's so, then that means we can find an integrating factor. Okay, our n is equal to what? xy. Derivative of m by y is equal to 2y, and derivative of n by x equal to y. So we would get y over xy, which is equal to 1 over x. Is this a function of x only? Yes, it is. So that means we can find an integrating factor. So then our integrating factor is equal to exponential of integral of fx dx. Now our fx is equal to 1 over x dx, so we would get exponential of ln x, which is equal to x. So then I said that, okay, multiply the differential equation by x, right? X is our integrating factor. So you would get x times x squared plus y squared plus x dx plus x squared y dx equal to 0. Now we are going to check it again whether it is an exact equation. Now our m is equal to x times x squared plus y squared plus x, and our n is equal to x squared y. We do differential of m by y. We would get what? Which อันไหนครับอันนี้เหรออันนี้มันเป็นอะไรนะอ๋อ dy ใช่อ่า and then derivative of n by x